With me is Alex Filipenko, an American astrophysicist and a professor at the University of California, Berkeley. He was a member of the team that received the 2011 Nobel Prize for discovering the dark energy that is speeding up the expansion of the entire universe. And he believes that it could have sprung into existence without any divine help whatsoever. Well, now we will have a chance to talk about this more. Thank you very much for joining me here today.
It is a pleasure to be here. Thanks.
So you maintain you do not need any divine help to explain how the universe came to be. So what is your version?
Well, let me start by saying that I'm going to discuss the universe only from the perspective of a scientist, from an intellectual perspective. I'm not going to be talking about whether there's a spiritual God or a personal God or a purpose to the universe. These are questions that science can't address. My own belief is that once you have the laws of physics, the universe just keeps going on its own. And it could even be that the laws of physics are all that you need in order to get the universe to start from the very beginning, the Big Bang.
What is then the origin of the laws of physics?
So that's a great question. What is the origin of the laws of physics? I don't know. That's a question science can't answer. What if the laws of physics have always existed and they give rise to a universe, our universe, and perhaps even multiple universes? That's a possibility, but it's a possibility that's sort of outside the realm of science because we don't know of any way to experimentally or observationally test whether that's a correct hypothesis.
So let's start from the very beginning. What gave rise to the universe? Why was there a Big Bang?
So what gave rise to the universe is an interesting question. We don't exactly know the answer to that, but we have some ideas. For example, if there was a pre-existing universe, then what's called quantum fluctuations, little bits of energy coming into existence for a very short time and then usually disappearing, well, those can occasionally give rise to a universe, because if a quantum fluctuation lasts for a long time, it can grow to a very large size, and that can essentially give rise to a universe. And that universe might then have quantum fluctuations that produce other universes. So that would be a never-ending sequence of universes arising as a result of just fluctuations in energy in existing universes. That's one idea. Or another possibility is that there was some sort of a hyperspace, some sort of a mathematical space in which the laws of physics existed, and then universes just sort of pop off like little soap bubbles that a child might blow. So there might be all these soap bubbles which are like different universes in a much bigger hyperspace within which the laws of physics operate for unknown reasons. You see, it all starts with the laws of physics, but I can't tell you where they came from. What's very beautiful to me is that a very small number of laws can explain the vast complexity around us, with the one exception where we still just don't know, and that's life and intelligence, okay? We just don't know. Biologists have not advanced far enough to understand exactly how life arose and how intelligence arises. But the mechanical universe is amazingly complex, yet explainable with a few simple laws.
Scientists have just announced the discovery of Higgs boson. What do you think? What does it tell us about the origin of the universe?
The Higgs boson helps complete what's called the standard model of particle physics. There's a way we have to try to understand electrons and quarks and neutrinos and other kinds of particles. And the Higgs boson was kind of a missing piece of the puzzle, which, if it were not there, would mean that we'd have to kind of start over. But the fact that it appears to have been found completes our picture of the standard model of particle physics. That's not to say that we understand everything. We don't yet understand how gravity fits in with particle physics, other than the fact that gravity, pulls particles together.
Right.
We also don't understand things like dark energy. The universe seems to be filled with a dark energy
that's my next question.
It's expanding the universe faster and faster. I helped discover that. And the 2011 Nobel Prize in Physics was given to the team leaders last year for that discovery. So we don't understand the dark energy. There's also something called dark matter. It may or may not be some kind of fundamental particles that could be part of the standard model. We don't yet understand. So the Higgs boson is a very important discovery, but it does not solve all questions that remain in physics. But it is a very important discovery. In a sense, it would have been more exciting as a scientist if it were not there to me, because it would mean that we're not correct in our view of the universe. And the surprises are more fun than the expected discoveries. Sort of like we expected to find that the universe is slowing down. Just like when I toss a water bottle up, it slows down due to gravity of the Earth, pulling it down, and eventually it stops and brings it back down. Well, we expected all the galaxies to be pulling on each other and to be slowing down the expansion of the universe. But instead we found that the expansion is speeding up. So that meant that there's something totally brand new that was unanticipated, that we don't understand. And for a scientist, that's more fun than just confirming something that you already thought was there, something that you already thought was true.
Were there any unanticipated discoveries among scientists?
I don't think scientists will ever truly understand creation, because I don't think we'll know where the laws of physics came from. But given a universe, given that universes can arise, I think someday we may well understand dark energy and dark matter and the other constituents of the universe. We only discovered dark energy 14 years ago, the accelerating expansion of the universe. So it's no surprise that we don't yet fully understand dark energy. Dark matter was only conceived a few decades ago. So again, we don't yet really know what dark matter is, but we've not been investigating it for very long. I mean, in hundreds of years, who knows what we will know? We might have a full inventory of what's in the universe and how everything behaves. So we will know a lot, but we won't quite know why it all happened and why there's something rather than nothing. Why are there any mathematical laws of physics rather than just nothing at all? I don't know that we'll ever understand that. Scientists are only well aware of 4% of the universe. That is, we understand pretty well the nature of 4% of the universe, the stuff that is made of atoms. 96% of the universe is made out of dark matter and dark energy. And although we know that they are present, we don't know what their detailed properties are, or why they are there, or what exactly is going on. So, in the past couple of decades, there's been a true revolution in our understanding of the universe. What we used to think of as being everything is actually only 4% of the pie. If you think of a pie with slices, 4% consists of the normal stuff of which we are made.
But this is fascinating.
It's fantastic, that's right, yeah. And so you can see that our view of the universe as scientists changes. And that's a strength of science. Scientists are not afraid to say that they used to be wrong. Their view of nature was incomplete. We love finding new things and coming up with what we think is a more complete description of nature. That's the fun of it. We don't take anything as an article of faith, other than perhaps the existence of the laws of physics. But everything else we try to understand from those laws of physics. And with time, we're coming to a better understanding of the laws themselves. For example, I said that there are 4 fundamental forces. But in fact, in high-energy colliders, like the Large Hadron Collider, they're smashing particles together so much, with such great force, they found that the electromagnetic force, what holds atoms together, is very similar to, and in fact the same thing as what's called the weak nuclear force, which is a very strange force having to do with neutrons. They behave the same way when particles have very high energies. So in a sense, there's only three fundamental forces. And there's a suspicion that the electroweak force and the strong nuclear force, which is what keeps protons and neutrons together in a nucleus, they might become the same force at even higher energies, leaving a grand unified force and gravity. And then in the theories of everything, string theory is one attempt to do this. They are trying to unify this grand unified force with gravity, meaning that fundamentally there might be just one concept, one force, and these four forces we see in today's low energy world are simply different manifestations of one fundamental concept. That's the goal of string theory, is to figure out in its most basic way how the universe works.